stuff. So I want to kind of narrow it down now and get into specifics. So there's a fair amount of notes here, but these videos are going to be online. So if you don't want to write any of this down, I probably wouldn't. If you need to go back, just look at the video and you can write it down. So it's probably easier if you just listen and you can add your own little notes that make sense to you when you convert what I say into normal English. Right. So let's look at one topic, just one specific thing. How do statistics, how do they look at data? Well, the first thing we do is you try and split it into what kind of data are you dealing with, because it's not just everything you get is a number, right? There are different qualities to it, different depths of what kind of data you get. So the first branch is that data splits into two main groups. One is called qualitative, and the other is called quantitative. Why is that such a hard word to spell? There we go. Right, qualitative is data that really isn't a number, even if sometimes it looks like it might be. So if I was asking you what's your favorite color, the answer, the data I would get back is red, blue, green, right? That would be an example of qualitative data. I could ask you what countries you've been to. That would count essentially as qualitative data as well. Then there's things that look like numbers, but they're really just qualitative. An example of that would be if I gave you a scale of 1 to 5, where 1 you were definitely against whatever it is, and 5 you were definitely in favor of it. Although the answer might be I'm a 3, which is a kind of sitting on the fence kind of opinion, or I'm 5, go for it. That's definitely what I believe as well. Although that is a number, really it's just a label, right? That is allowing us to say, I'm definitely against it, I'm in the fence, I'm sort of for it, I'm really for it, right? So those types of things that you get as well, they're called Likert scales, but you don't need to know that. So I'll just put down like a cover, opinion, right? Those count as qualitative things, right? Numbers can sometimes fall into that category. There is a couple of other ones which I'll describe as codes. If I went and said to you, I went out and I collected randomly a sample of 100 people's telephone numbers. Why? Who cares, right? I did it. If I took that 100 telephone numbers and I found the average of them, in other words, I just added those numbers up like they were 22,000, right? That kind of thing. And I divided, I would get the average telephone number. Would you agree that that's a stupid piece of information? It has no meaning. If I did the same thing with your social security number, right? I would never do that. But if I collected your social security numbers, right? And I found the average of 50 people's social security numbers, in those cases, it wouldn't make any sense at all. Or the numbers on American football players, right? If I randomly picked 50 American football players and said, what's the usual number you use? In that case, again, the average would not be useful. So those are examples of what we call codes. So it might be that you collect data and it says 1, 7, 22, and 9. But if you really are only using that as a code, then it belongs in the qualitative world, right? Now, in the quantitative world, we have two kinds of data there as well. Quantitative are basically numbers. Right. And what could be that? Well, it could be the number of children in your family would be an example of that. How much money you make. What is the temperature today? And so on and so forth, right? Your average age, right? What ages people, right? Quantitative are numbers. And there are all sorts of nuances within those numbers, and there's some nuances within the qualitative. But in general, if you're a real number, right, a true number that makes sense. So what do I mean by that? Couldn't you find the average number of children and it would make sense? Couldn't I find the average age of OC students and it would make sense? Could I find the average number on a football jersey? Yes. Would it make sense? No. Can you see how that number is qualitative, but number of children is quantitative, right? So you're going to get questions like, here is something. What is it? Qualitative, quantitative, right? And that's how you can kind of tell. Now, what are the nuances within that? Well, when you look at qualitative things, there are two kinds. Nominal and then ordinal. So if you're looking at a piece of data that isn't really a number, right? It's a code, if it is, but it's basically red, green, blue kind of thing. If you can put it in some kind of order, then it's an ordinal number. And if there's no sensible or obvious order, it's nominal. So let's try and give you some examples of that. I think I've got some here. Nominal is data that typically isn't a number and it has no obvious order. For instance, ask someone with a favorite color, right? Imagine I got 22 said red, 14 said blue, 18 said yellow, whatever it was. Couldn't you basically put those colors in any order? And there's no right order. I guess alphabetical, but forget about alphabetical. Apart from that, there is no right order. That is an example of a nominal piece of data, right? That's qualitative, but it's nominal. Can you put it in order? Because sometimes you can. For instance, if you had were you a freshman, a sophomore, a junior, or a senior, right, at high school? Can you see there that there is a natural order, isn't there? Freshman to senior. So that would be still counts as qualitative, right? It's a word. I'm a freshman, right? But you have an order to it. Do you know that 1, I hate it, to 5, I really like it? Doesn't that have a natural order as well? So it's qualitative, but it has got an order to it. I like the word ord because it reminds me to remember ordinal, right? It's got an order, ordinal. Nominal, no order. Then you move on to the two kinds of quantitative data. And there's two of these. You have on the highest level is called ratio, and the not so good, but still a number, is interval. We talked a little bit about this before. Here goes. If you have got a number, the question I typically ask myself is, if I said one of the things was twice as big as the other, is that a true statement? So if I went and said to you, suppose you found two people's heights and one was 4 feet and the other person was 8 feet. Would it be correct to say one is twice as tall as the other? And the answer is yes. In particular, if you change their height from feet to inches to centimeters to whatever you like, won't the two numbers still be twice the other number? Right. So that property is called the ratio property. Ratio is just a fancy name for dividing two things, right? So how much money I've got is ratio, right? If I've got $50 and someone else has got $100, isn't it accurate to say that the other person has twice as much money as me? Most numbers that you are likely to meet, most, but not all, fall into that ratio category, which is why you sometimes get caught out with the rarer subgroup called interval. In these questions, it's still a number, right? It's 42, it's 70, and it's a real number. And you can find averages and do all the usual things. And you can even subtract them and it makes sense. But you can't do the ratio. And the one that I think is the easiest one to do is temperature. That's the most common one I can think of. If I said to you it was 50 degrees centigrade and the other temperature was 100 degrees centigrade, a lot of people think that means that this temperature is double that. It doesn't. It just means this number is double that. It's not the temperature. Because if I converted these two temperatures into degrees Fahrenheit, wouldn't those numbers not be double each other? Now, I don't know off the top of my head what they are because I'm used to centigrade and I'm not so used to Fahrenheit. But can you trust me? I'll pretend I know. That's 83 and that's 213, right? You see, they're not double each other. So if you're looking at, I've got a number, but I'm not sure if it's ratio or an interval, try and ask yourself that doubling question and then say, if I change the units, right, what I was measuring it in, would it still be double? And if you say, yeah, money counts as ratio. Okay, he's got $100 and I've got $50. He's got twice as much money as me. See, if I took that money and turned it into francs, wouldn't he still have twice as many francs as me? If I turned it into pennies, wouldn't he have twice as many pennies as me? You see, the ratio doesn't care what the units are. It's still twice the other guy. And that's essentially how I would look at these questions. So we've kind of started off with data. Are we comfortable with the two major groups and the two subgroups within these major groups? You feel you can tell the difference, right? Okay. So what I'm going to do now is nip over to the homework and we'll see what kind of, oh, darn it in space. I hit the wrong thing. Never mind. Try it again. What the heck is that? I thought I'd set something up, but evidently I haven't. So you're going to have to wait a few seconds. Here we go. And let's do a view. Okay, I think we're ready to share that. And I have to close a whole load of windows. There we are. And get back in. I should be up and running now. Here we go. Right, are you all looking at homework questions? Website. Okay, let's just go through some. Are data at the nominal level of measurement quantitative or qualitative? So if you're nominal, which of those two big categories do you belong in? The qualitative or the quantitative? And there's 4 choices. What's the answer?
Qualitative.
Oh, yeah.
There you go. You see how easy your homework's going to be, at least for this section? Right, here is a story. This is question 5. Numbers are often assigned to data that are categorical in nature. There's, you know, there's different categories. So here someone's asked a question and they attach a code to it. So they ask you, describe the electronic ways of expressing a personal opinion. And some say I text, I email, I Facebook. You see 1, 2, 3, 4, 5. There is a number to them, right? Now, are these numerical assignments at the ordinal level or higher?
Wouldn't they be at the nominal level?
I would say so. And hopefully that's the choice, is it? Oh, I would argue with the book, but I'll tell you why they're choosing it. They haven't just said Twitter, email, text, Facebook, and blog. If they have done that, do you see that they're attaching some number to it? So I think that's why they're saying that it is ordinal. But me personally, I think that data could be, couldn't I rearrange the coding and it wouldn't change really anything? So I guess sometimes we disagree with each other. Now, this one, on the other hand, I think that coding system is quite sensible. Would you agree that this definitely is got an order to it, so it is ordinal? right? You know, at one level, not helpful to, in this case, 4, very helpful, right? And then it asks about that. That's not very interesting. Let's see another one. Okay, this one. Here we have a whole load of things, and we have only 4 choices. And so the kind of question is basically, here is a variable, right? The thing you've measured is called your variable, and we're being asked to look at it and decide which of the 4 categories. Right, the length of time to complete an exam. 4 choices. Which one would the length of time to complete an exam? Look, I'm going to be retiring in a few years. I'd like to get a question answered before then.
Would it be interval?
Would it be interval? That's a good question. If it wasn't interval, what would be your other choice?
Ratio.
Right, let's see which one it is then. If somebody took 45 minutes and another person took 90 minutes, would it be true to say that one of them took twice as long as the other?
Yes.
No. Or,
I
yeah.
would. Isn't 90? And that's what I asked myself. I asked myself the double question, right? If one of them's twice as big as the other, does that make sense? Now, how do you double check that? Suppose I turned the answer instead of minutes into seconds. Wouldn't one still be twice as long as the other? Don't matter if it's minutes or seconds or hours or fractions of an hour or any other thing. What about the time of the first class? One class starts at 1 p.m. and the other class starts at 2 p.m. Is it correct to say that the one class starts twice as later? I don't even know how you phrase that in grammar. Not really. Agreed?
Mhm.
It's still a number, but it doesn't have that ratio quality to it. You know, isn't 1 p.m. Couldn't, for instance, 1 p.m. if you're military be called 1300 hours? And wouldn't 2 p.m. be 1400 hours? Is 1300 and 1400 twice each other numerically? See, it doesn't work. I'm just skipping about. The age of a student, right? So you collect two students, and one of them's 40 and one of them's 20, right? So we'll do the double test. Would it make sense to say that the one of them's twice as old as the other? And if you wrote down their age in days, wouldn't they still be twice as old as each other? Right. So think of the answer and then change the units and think of the answer. If it's still yes in both cases, you're looking at ratio. If it would change because you changed the units, right? You changed from minutes to seconds or something, it wouldn't be the same. Then that would be interesting. Okay, here we have another bunch of these, and then I'm going to move on to something else because there's lots of things to cover. C, the names of new products, right? So whatever it is, you know, fresh air, stinky air, blue air, and black air, right? Whatever, right? You get four products. What level would you call that data?
Nominal.
Nominal. Would you agree there's no particular rhyme or reason, at least the way I just phrased it? Temperature in an office in Fahrenheit.
Interval.
Interval. Remember we talked about temperature before. I don't care the context of the story. Temperature is kind of guaranteed to be interval in every situation you could ever use it. Your gross income for each of the past 5 years, right? How much money you made before they took the tax and stuff. What kind of data is that?
Ratio?
Yeah. I made twice as much as Joe. If you turned our money into pennies, I still make twice as much as Joe, don't we? Whether it's dollars or pennies or convert it into francs and, you know, whatever. it's still once, twice as well. Money tends to be that. Money tends to be guaranteed as ratio in every context I can think of, and interval tends to be in the other. So far so good. So if I gave you a question and it was concerned with what kind of data have we been collecting, then hopefully you'll feel comfortable about answering that question. Is there anything that you want me to clarify on this stuff, or are we good? Feel comfortable with that? There are 4 guys in town. 2 are called quantitative, 2 are called 2 are qualitative, 2 are quantitative, and the nuances of each. Next thing I'm going to look at is, I don't need that really, is terms used in statistics. A lot of chapter 1 is just getting you into the vocabulary. You know, we don't just say it's a number, we say it's, you know, it's an interval, or we say it's a ratio. We don't just blanket everything in one thing, we have nuances to that. So I've got some of my answers here, so I guess, so I don't have to repeat myself. I'll use at least this bunch, that way I can talk about them. Here we go. Lovely one. There we go. Population. In statistics, when you talk about a population, it's everybody that you're interested in. And that population changes depending on the question or the information you're trying to get, right? For instance, if I'm trying to find the average age of people who live in Washington State, then the population there is everybody who lives in Washington State. I don't go to New York and find some people there and find out what their age is, because that's not who I'm interested in, right? So the population is only that group of people or things that you're interested in, right? If I was only interested then in the average age of people in Bremerton, then the population would only be people who live in Bremerton. So I wouldn't go and ask somebody in Seattle, you know, and so on. A sample is what we call a small group of people from the population. And typically, since you can't really ask everyone normally, you just ask a small group of people, and hopefully they're a fair representation of that group. A population parameter is some number that you get from your population. For instance, if my population was people in America, right, in this general one, if my population was people in America, one of the parameters might be the average height of an American. Another population parameter might be the number of children in their family. Another parameter might be what level of education did they get to, right? So a population parameter is just a single number typically that is kind of a summary of everybody in that population. And most of the time, that's what we're interested in trying to find, what that number is, that population parameter. But we can't typically ask everybody, so we do a sample. And a sample statistic is the same number that you're trying to get from the population. So if I wanted to know the average age of a person who lived in Bremerton, couldn't I maybe just find 100 people in Bremerton and find their average? My sample statistic would be their average. And we tend to write that with a little X bar. And can we just pretend that I did it and it was 35? So that's my sample. It was what, 100 people. And that's from a sample. But suppose we were using that sample to figure out what the population average, right, the average age of everybody in Bremerton is. Is the average age guaranteed to be 35? No. Isn't there a bit of variation? It just happened to be the 100 people I asked. Couldn't I, by bad luck or whatever, ask maybe a few older people, and so the average is a bit more than it is for the whole population, or a bit less? Can we pretend that somehow or other we actually asked everybody? And it wouldn't surprise you, I hope, that it might have been 34.2, right? If you do a good sample, shouldn't it be at least close to that? It shouldn't be miles off. And we have a funny little Greek letter. When it's a population mean, we use that funny little Greek letter, and when it's a sample mean, we use that. You say this guy out loud as X bar, and you say this guy out loud as mu, the Greek letter mu. So if somebody says the population mu equals 34.2, you know that the population mean was 34.2. And if they said the sample X bar was 35, you know the sample mean was 35. Cool? How about this word? When we use the word variable, we use that to mean the data that you are collecting. From the population. Right. So suppose I was collecting how many children were in your family, right? So that was my data. Then the variable would be number of children in your family. Suppose I was collecting the percentage of you that own a home, right? Then the variable here would be percentage of people who own a home, right? So whatever you're collecting, it could be height, weight, age, how much money you got, how many cars you own, whatever it might be, that is called a variable. We good? Right. So when I'm not going to go back to the homework this time, but what you're going to get in the homework question is a story, and then they'll say to you, who's the population, who's the sample, which one of these is a variable, and so on and so forth, right? So it's going to be, here's a choice and you pick one kind of thing. So that's kind of how that would work. And Monday, we covered some of the other topics, so I'm not going to regurgitate them. We've got a big chunk of nomenclature, right? Words, the jargon from stats. So where are we off to now? Well, how to collect data. There are two main types. One is called observational. Very often it's called an observational study. And the other one is called an experimental experiment. So those are the two main ways in which we collect information data. We either do it by an observational study or we do it by an experiment. If you're in the science world, you almost always get your answers from experiments, because experiments give you a great deal of control about who you ask, when you ask them, and what you ask. An observational study is less significant information, because basically you don't really control anything. You just observe, you just watch. So the features of an observational study are that there's little or no control. That's its main feature. So I'll give you an example of an observational study. They're sometimes conducted in things like psychology. And what they might be doing in, say, child psychology is that they'd have a camera and they'd watch children playing. And they'd take note of how many times little boys hit other little boys when they're playing, how many times little girls hit little girls when they're playing, and how many times, you know, little boy hits girl, little girl hits boy, right? And they collect that. Now, can you see that that's them just watching and seeing what happens and writing down, oh yeah, 22 times a boy hit a boy, 5 times a girl hit a girl, and then 3 times, you know, it was one of the other combinations. And then they would say something like, from our observational study, it looks like little boys, even when they're really young, are more violent than little girls, right? They hit each other more often. And they come up with kind of conclusions based on observations, right? They didn't do anything to control what was going on. They just looked. Another kind of observational study is a retro observation. Happens a lot in the medical field. Can you imagine, and this is a true story, although the details might not be completely accurate, the gist is. Pregnant mothers were having a large increase on babies who were born without fully formed limbs. And normally that happens, but it is very, very rare, right? Just natural bad luck, it happens, right? Very rare. And it took a couple of years, and doctors were getting concerned that it was happening a lot more than it used to. And they went back and they looked at the women who that happened to, right? And they looked at what medications they were taking, that they took. Right? And does anybody know the name of the drug that I'm getting at? Thalidomide.
Is it like Accutane or something?
That might have been the American version. In Britain, it was called thalidomide. It was basically a very innocuous drug. It was to take, pregnant mothers were just to take it to help them with morning sickness, right? It was the kind of drug that you would think would be low down on the danger level, right? But they found out that that was the drug that was actually influencing some mothers' cases, their baby's development, and that's what happened. And there was a big court case, and you know, pharmaceutical get sued, and all the usual things that happened after that. But that was a retro observation. In other words, some years had gone by, and doctors were saying, I don't like this. There's something going on here. Let's go back and look at past data. What were these women taking? What was their medication? What were their lifestyle? Were they smoking more? I don't know. Like, they looked at everything. And then one major kind of thing that almost all of them shared was that they took this drug, or a generic version of this drug, whatever the Americans called their version, right? And that would be an example of a retro observation. Can you see here, there was no control over it. They just watched, in the sense that they looked back at something. If you were going to do this same thing, but you wanted to do it as an experiment, it would be totally immoral, but this is how you would do it. You would split pregnant women into 2 groups. One group would get the bad drug, right? The one we think is causing all the trouble. And the other would get what is called a placebo. A placebo is just a sugar pill. It has no active ingredients. There's nothing in the world that should help or hinder you if you take a sugar pill, right? So just a placebo. But they do it because they don't, in this case it probably wouldn't matter, but in many cases they do it anyway just to be scientific and have 2 separate groups. As they looked at how many of each group had children that were born with malformed limbs. And this lot had a lot of them. Lot can mean just 2%, right? And this one had almost none. You know, like 0.01%. The only difference between those two groups, right, was the drug they took. And if one group has a significantly different result than the other, it seems logical then that that drug is the major cause of that problem. Now, can you see why you can't do an experiment for thalidomide? You can't deliberately put pregnant women at risk just to prove that this drug is bad, right? So it's not that observational studies are bad. Sometimes they are necessary because the alternative is really bad. Right? I don't want to give people bad drugs just to prove that they're bad, right? But for that same reason, it takes a lot more evidence to prove in retro observation. And you might say, well, how could that be? Here's a true example. Everybody today, I think, with very few exceptions, would agree that smoking cigarettes is certainly bad for you, health-wise. And would you agree that it increases your chance of getting various cancers? I think that's universally accepted, right? Do you know that wasn't universally accepted 50 years ago? In fact, if you see old movies, you'll see people smoking cigarettes like nothing was going on. A retro observation started noticing that a lot, not everybody, but a lot of people who had, say, lung cancer were smokers. And most of the lung cancer people were smokers. In other words, it was a kind of niche group. Now, do other people get lung cancer? Sure, but they're a much smaller group. And so they figured out from that smokers had a higher incidence of lung cancer than non-smokers. And that was the first warning sign. And so they started saying, look, smoking causes cancer. And then people said, wait a minute, we agree with you that if you smoke a lot, you're in that group that gets cancer. But we don't agree it's the smoking. And they say, what do you mean you don't agree? Well, do you know that the people who smoke a lot are a special kind of group of people? Do you know that they they don't exercise as much, right? You don't get many marathon runners who smoke 40 cigarettes a day, right? You just don't. They don't exercise as much as non-smokers. They don't eat as well as non-smokers. They may work in industries which are very unhealthy and stressful, and they smoke. So why couldn't it be any of those other factors and not the smoking? Maybe it's just bad lifestyle. And smoking is just one small piece of that bad lifestyle, but it's not necessarily the major cause. Do you see how difficult it is to get proof now? And it took a lot of heavy duty statistics. You know what they actually had to do? And it's really hard to do. They had to look at data where they looked at 100 people who are marathon, I'm making this up, but 100 people who were marathon runners, right? And who smoked a lot, and 100 people who were marathon runners who didn't smoke. And they looked at how many had cancer. And 100 people who were couch potatoes and got cancer, and 100 people who didn't smoke, and what percentage got cancer, right? Going through every single feature and factor that they said. And no matter how you cut it, the smokers always came out worse on the lung cancer side. Now, if you wanted to do this, you'd have to be in Nazi Germany. If you wanted to do that same smoking causes cancer, wouldn't you have to say, okay, I'm randomly going to select 2,000 healthy adult males, and I'm going to just randomly break into two groups, say 500. And the first group, you're going to smoke 200 cigarettes a day. We're going to make sure, right? We'll shoot you if you don't. And the other group, you're not allowed to even go near a cigarette. If we see you, we'll shoot you, right? Whatever it takes to make that happen. And you let them smoke, and maybe it'll take 10 years. And you let that happen for 10 years. And at the end of 10 years, you look at the two groups. Can you see now that there's only one difference between the two groups, right? You told them to do everything else that they always did in their life, right? So if you were a couch potato, still be a couch potato, right? The only difference then between those two groups then, wouldn't it be the smoking? Everything else, each group did the same kind of things at the same ratios. And that's how you would get the evidence. So we have observational and we have experiment. What makes experiments different? You do have control. Can't you choose how many people are going to be in your experiment? Right, I'm going to get 2,000 people, I'm going to get 2 million. Can't you decide to randomly split them into groups? You can decide how you want to split them, right? Can't you decide which group you're going to give the pill to, or the smoke, or the cigarette, and which group not to? Control. Any information you get from an experiment, especially this two-group situation, is very strong evidence. If there's any difference between the two groups, if you design it properly, it's because drug is bad. Smoking gives you cancer, right? This is just my personal opinion, so it can be totally wrong, probably is, knowing me. Marijuana is legal now. I know it was illegal, but now it's legal, right? Is marijuana smoking bad for your health? Well, we can't do an experiment. We are not allowed to get 400 Americans and say to 200 of them, here, smoke 50 marijuana. I don't know if marijuana is a cigarette or whatever. I've never smoked in my life, but here, do 50 of these guys every day for the next 10 years. But do the rest of your life, right? Do whatever it is you normally do, right? If you swim a lot, keep swimming a lot, right? If you eat badly, eat badly, right? And at the end of 10 years, we'll come back and we'll see what kind of health issues each of the two groups have. And if one group, the marijuana smokers, I strongly suspect, have some issues that are different from the other group, then isn't that the evidence that marijuana smoking is going to cause insert illness here? Now, it might not be cancer this time. You know, heavy marijuana smokers may end up having a higher incidence of, can I say the word today, schizophrenia. I've actually seen some very low grade, not very good ones done in Europe where it's been legal for longer, that marijuana smokers do have a higher incidence of some mental disorders than other people do. Whether that's true, I don't think I want to say that because it's been quite early. You know, it takes you a long time to get cancer from smoking. It'll probably take 10, 20 years from now before the marijuana health issues we actually have evidence. And it's going to have to come from retro observations. It's going to have to be doctors, you know, when they ask you, are you a regular marijuana smoker, right? Or something like that. And then collecting data on what age they die at, what kind of diseases did each group have. And then if there's anything significant, it'll eventually come out. I strongly suspect that it does. So my advice to you is don't smoke marijuana. That's just me. Up to you whether you take that advice or not. Are we good? Right, any questions? Right, here's a term you're going to see sometimes. You might have seen it before. The fact that the word experiment tells you it belongs here, right? It's a special kind of experiment called a double-blind experiment. Typically, you have two groups. One group gets the stuff. These are very often called the treatment group. And the other doesn't get the stuff, and this is called the control group. So if you do an experiment, and you have two separate groups randomly selected, right? So the people who go into either group is just random. You go into group one, you go into group two, that's done. The group one get the treatment, right? They get the pill or whatever it might be. The group two get control. So what would that might look like? Giving you a story. A drug manufacturer has got a new pain pill, right? If you take this, it reduces your headaches, right? It's a bit hard to measure pain because, you know, it's very subjective. Some people's pain threshold is quite low. Some people, you could almost cut their arm off before they really feel pain, right? That's an extreme, but that's, so what they do is they give you a scale, right? On a scale of 1 to 10, 1, I feel nothing, right? No pain at all, right? I'm fine. Maybe up to 10. 10 is kill me now. I'm in agony, you know, whatever it is, right? You have this kind of scale. And you people who have that are given the treatment, right? And you see what they have. There is a thing called the placebo effect. And the reason why this group, right, the control group, are very often given a placebo is you just give them a sugar pill. So they say, when you have a headache, you take this pill and you swallow it. And then wait half an hour and tell us, is your headache better, worse, or the same? And then the other group get the painkiller. Now, what's this weird thing called the placebo effect? Has anyone ever heard of it? The placebo effect.
So it's like when people take some, like for example, the people who took the sugar pill, they won't know that they're taking the sugar pill. So they'll think they'll have something that actually has a real effect. And so they'll like trick their minds into thinking that they actually feel better.
Yes, it's pretty much, I couldn't have said it better. Exactly. And for certain situations, the placebo effect is very strong. In other words, it does have effect. You know, if you take a pill and you truly believe it's going to reduce the pain that you're feeling, you know, very often, if you believe it's strong enough, you will feel less pain. Your brain, isn't pain just your brain sending a signal saying, I don't like this? And if you can con your brain into it's not that bad, then the signal it will send will be weaker, and therefore you won't feel as much pain. So, I mean, it isn't just psychological, it is a physical phenomenon, right? It does actually do stuff. Now, it works better in some circumstances than others, but it is a known effect. The result is that the people who are in these two groups, they do not know which pill they're getting. They don't know if they're getting the real pain pill or they're getting the placebo. That's so that the placebo effect doesn't matter, right? Because nobody knows which one they're getting, so the placebo effect is neutralized, right? It spreads among both groups. But they added another feature to that, and why it's called a double blind. See if it's only the people who are getting the pill don't know, it's just a blind experiment. That's the name. But it's called a double blind experiment for a different reason. The people who are in these experiments very often have a doctor or some person in charge of collecting the information. And in many experiments, isn't it your own doctor? And you go and see them once a month and they collect data on, you know, how's this affecting your headaches now? And the doctor who is collecting the information for the pharmaceutical company or whoever it is, the doctor doesn't know either whether their particular patient is getting the real pill or the placebo. And that one's less obvious. Why does the doctor not know? Or why should the doctor not know? Has anybody got an explanation
If
why?
the doctor knows, it could cause them to interpret the data in a biased way.
Yes. And they can also, that's totally correct, they can also do this. Can you imagine you're going to your doctor and they know that you're getting the placebo? And as they're talking to you, they say, how are your headaches? What are they like? Do you see that they're conveying to you that they shouldn't be any better than they were, right? It's not working. Because I know you're getting a sugar pill. You know, they can project, even although they don't even know they're doing it. Subtly or psychological, whatever the word I'm trying to think, they can project onto you and influence your answer where you start thinking, yeah, this pill can't be working. I'm getting a vibe off the doctor that this pill's not very good. And the minute you do that, you can have the anti-placebo effect where you believe it's not working. It's kind of, your brain is a weird object. You can influence it in two directions, and that's what double blind. As many experiments are possible use the double blind structure. The data you get from it is really good, really powerful evidence. And pretty much most pharmaceutical companies that have to prove that their drug is allowed to be used go through various stages. The first stage is actually just testing, is the drug safe? Right? Are there any nasty side effects? Once it gets by that, they then enter the, does that drug actually, is it effective, right? Does it do what it's meant to do? And if it gets by that second hurdle, then that drug becomes something that would normally be put into open usage. So right now we're in the COVID-19 thing, and they've reduced the time span to do this, right? And some people think that's a bad idea, that they should be speeding things up. Some people think it's a good idea. It's hard to tell. I wish I could tell the future. So here's two scenarios. Suppose you spend an extra year making sure that this drug is good. Do you know in that extra year, a couple of million more people are going to die? Because, you know, the vaccine is not out. Do you see the problem with making it too long? Now, suppose you put the drug out too early and it has nasty side effects. It could kill 2 million people, I guess. Wouldn't it be nice if I could look into the future and see which one of those two scenarios was right? And then I could come back to today and say, wait a year to make sure it's safe, or wait 2 years to make sure it's safe, or don't use that drug because I know it's dangerous. But we don't know that. And so we're always going to have to do risks, right? I don't know how the flutamide drug, the one with the babies, got by. I strongly suspect that it got by because it was a very small subgroup of pregnant women that it happened to. And so maybe the people, the pregnant women that they tested it on, it never happened to any of them. So they thought it was safe for every woman. Right, it's okay for 1,000, but if it's only 1 in a million, isn't that really bad for the poor mother who's that 1 in a million? So you're never going to be 100% safe, and unfortunately that is the way life goes. So let's look at some any questions? Let's look at chat. Anything in chat that I should be aware of? Oh, I like that comment. Someone says it feels like releasing early is worse because if it has a nasty side effect, it might not kill 2 million, but if it doesn't work, no one will use it, and you'll be back where you started. That is true. That is a scenario. Can you imagine that it also did work, but had a nasty side effect? I mean, if it didn't work, it wouldn't do it. But right now they're in stage 3. And stage 3 is that there's people in America and Britain and a lot of countries in Europe who are getting this drug. And half of them are getting the drug and the other half are not. And they're going to look at what percentage of each group gets COVID-19. From what I know, there's only been, and it was the British drug, the one done by Oxford, had one nasty side effect where it affected someone and had some inflammation of the nerves in their spine, but they got better. But that's the only one. I don't know if they have tied that in with the drug or whether that person just got a nasty disease that inflamed the spine and they got that anyway and the drug had nothing to do with it. But as far as I know, that's the only one that's had any noticeable bad one. If you're a gambler, I don't know. It's hard to make a good decision. I think it's one of those situations that if you do the right decision, people will think that you're great, but really you're just lucky. I don't think anybody can really say today with any degree of certainty what's the right thing to do. We'll know after the event, in which case there'll be a lot of people saying, see, I told you it wasn't going to work. They just don't tell me today that it wasn't going to work. That's the problem with those people, in my opinion. What do I know? Okay, anyway, let's, any questions about that while I'm setting up the homework questions, because I want to see if we can show you what those guys look like.
So the double-blind experiment is the one where your doctor does not know which pill you are taking?
Correct. You don't
Okay.
know, he doesn't know.
Okay.
A blind experiment is just you don't know. That's the difference between those. We got any experiments in here? I think they should be somewhere towards the end. You probably can't see what I'm scrolling through right now, which is fine once I get. I don't think they got any double blind here, do they? Oh, that's a bit unfortunate. I thought I'd put at least one in. No, darn it. Oh, here we go. Okay, I'll go out. Oh, you might see it. Are you looking at question 30 right now? Anybody want to answer that?
No.
No, okay, then it's out and in again. Here it goes. Spend half my day jumping back and forward here. Yeah, one day this software is going to be just easy and it'll just know what I want because it can read my mind. Okay, question 30 is connected to the type of thing that we're talking about here. So it says, how will you use a completely randomized experiment each of the following settings? And is a placebo being used or not? And be so specific and give details. Okay, so a charitable non-profit organization wants to test 2 different methods for fundraising. From a list of 1,000 donors, half were sent literature about successful activities that the charity had been worked on and said, can we get some more money? The other half were contacted by phone and asked to make a donation, right? So you either send out a letter and saying, here's 5 of the best things we've done. Can we get some more money to do some more of them? And the other half got a phone call saying, look, this is the cool stuff we've done. Can we get some more money? Okay. And then at the end of that, the percentage of people from each group will be compared. And once they've done that, what that I guess that would give them is an advertising strategy. Suppose the people who got phoned tended to send more money in, right? More often than not, they said, yeah, here's some more money. Then wouldn't you do a phone campaign, right? A full-blown, 1 million people phone campaign. And if the letter system worked better, wouldn't that be your go-to method? And so that's maybe why they're collecting that, right? So let's look at this. Randomly select 100 donors to receive the literature and 900 donors to receive a phone call. Do you think that would be a good way to split the 2 groups?
No.
No, I think that one would be a better choice, wouldn't it? If you get 500 in each group, doesn't that kind of give you a fairer balance between the 2 choices? If you make one group really small and the other group really big, aren't you kind of weighting one more than the other? And small groups are dangerous. Is a placebo being used? Or let's phrase it the way they phrased it. Is a placebo, is it not being used in this experiment?
There's no placebo because the people know that they're getting a phone call or they know that they're getting the literature.
Yeah, right. I can't even understand how you could do a placebo situation in that, right? Pills, I can see it. A lot of situations you can only do a blind experiment, right? You can just do an experiment, I should say, because it's pretty obvious if you're being phoned or not. Do you know if it's a surgical operation? It's pretty obvious that you're getting surgery on your leg or that you're getting a pill instead of surgery, right? You can kind of tell which group you're in because of the 2 treatments, if they're different enough, right? Okay, is there anything else in that list? Oh, here we go. After the donations collected period, calculate the average or total amount collected. That's an interesting phrase. Let's see how that might work. Right, suppose you give, you phone call some and you send letters to others. If you phone call the people, but they only give you $10 each, couldn't that add up to less money than fewer people all sending in $500 each? So I think it would make sense there, wouldn't it, to look at the average or the total amount collected to decide which method is better. Aren't you more interested in the total amount of money that you get and not how it was divvied out? So I would pick that as well. And I think I've skipped all the other good stuff. Right? So can you see there's a little story, and some of them we may argue about, because I can understand some of these are not clear-cut yes-no situations. But the book only has one answer, so you might argue after the event, nah, that's not right, or that should be there. Okay. This is not part of the question, but it's part of my brain. Based on your own knowledge or your own ideas, do you think people who get phone calls are more likely to help than people who just get mail sent to them? Think there's any difference? I mean, I guess that's
Probably
the choice.
depends on the demographic.
Oh, interesting. What do you mean?
Well, it depends the age of the person, I feel like, who's more likely. That could affect things.
Oh, yeah. So, God, I'm going to pick on one group. Older people who might be more likely to give you money than younger people, because older people might have more money than younger people. Right?
Yes.
You lot are students, so if you're anything like me when you were a student, you don't have 2 pennies to rub together, right? And so you might love to give a lot of money to all sorts of charities, but you haven't got any. So you might not be able to do it. I'm making this up, but can you guess what I'm saying? And whereas if you're older, you've got a full-time job and you've been working in your career for a while, so you probably get a good paying job, hopefully. If in that situation, you're more likely to have the finances and give more money. Is that the kind of what you meant by the demographics? Maybe?
I think you could also say that like younger people are like less likely to pick up their phone.
You could be right, but your voice was breaking up, so I couldn't hear what you were saying.
Oh, okay. Sorry, my internet's being really weird. But like younger people are probably less likely to like pick up their phone in the first place, for like if you were like
Oh, yeah.
asking for information.
Yeah, that is true. When I see something like that, it's kind of interesting because it gets me curious, and I think, I wonder what the answer was. I wonder if anybody's actually done that. A lot of companies do all sorts of things that you don't even know they're doing, but it's kind of, they keep it secret because it's part of their success. Now, I'm not talking about charities so much now, but companies that make stuff, they probably know the best way to advertise. Right? If I'm going to advertise to a 17-year-old, just take this right off the top of my back, there's certain things that 17-year-olds will buy, and there's other things that most of them won't, right? There are not many 17-year-olds who want to buy a brand new RV, right? It just ain't there. Would you agree that that's probably going to be for the older age group? Whereas 17-year-olds are probably more interested maybe in downloading music, or, the latest earphones, or the latest style of clothing and things like that. So can you imagine that if you're interested in that demographic, wouldn't you advertise in certain ways? Wouldn't you advertise more electronically to them? Because they're used to the electronic world. And if you were advertising to the older demographic, who maybe not as good, wouldn't written material and things sent through the mail, nice fancy brochures and that, maybe that'll catch their eye. Even simple things like, do you know in American football, the adverts between the games? Pay attention to this the next time. It's not a coincidence. How many of those adverts are geared towards teenage girls? Virtually none. Agreed? Beer commercials, truck, car commercials. Right? Why? The demographics of who watches that show. Right? So those are the kind of secrets. People have figured out what TV shows certain groups of people watch and so on. I don't know which one of these I should pick for our last one. Okay. Okay, here's one. How could this experiment be designed to be double blind? I need to look at. Oh, this is part of B. Okay, a tooth whitening gel is to be tested for its effectiveness. So a group of 85 adults have volunteered to participate. It's roughly equal group, 43, 42. And 43 are given the gel that has the tooth whitening. The other 42 are to be given a similar looking package of gel that doesn't have any whitening. That is the placebo that they're giving them, right? So they're getting stuff and they're brushing it. Okay. How could this experiment be designed to be double blind? Now, a standard method was used to evaluate the whiteness of teeth for all participants. Then the results of the two groups will be compared. Right. It says, how could this experiment be designed to be double blind? Well, the patients, I'm assuming, shouldn't know which gel they're getting. It's not good saying, here, you're getting the whitening stuff. We're just giving you this stuff that doesn't whiten. We're just doing you as a control group. Well, the minute you tell people they're the control group, isn't the placebo effect going to disappear right away? Or is going to take part, I should say. The treatment administrator will not know which gel the patients are receiving. That's basically the person who is checking how white they are, right? And the patients would not know which gel they are or the other patient are receiving. I think that's the same as this one. Read that again. The patients would not know which gel they or the other patients are receiving. Well, I guess you only need to know yours, so that's not quite the same. And the last one, neither the treatment administrator nor the patient knows. That's a double blind, isn't it? The guy who's measuring the whiteness doesn't know what you're getting. You don't know which one you're getting. See, if the guy who knows that's the gel whitening, see when he does a standard test, isn't he maybe inclined to think, oh, she's getting the gel, hers is probably a 3, not a 2, you know, whatever. It kind of influences the way he sees things. Are we good? Right, now, there is a lot of stuff in that particular section. I haven't covered all of it, but if you read chapter 1, there's lots of cool things and you'll get whatever you need from the stuff I've missed. So what I want to do for the rest of what's left of today is to start the next section so we can get a little head start on it. And this is how to summarize your data. In particular, I'm going to look at frequency tables. And that's all, because we won't have time to do the next part. But I'll put down what the next part is anyway. The next part is histograms. So we are talking right now, how do you summarize data? And I guess I should have said, how do you summarize numerical data? So you're collecting true numerical, right? It could either be interval, it could be ratio, but really numbers, right? Not codes or anything else, but just numbers. And how do you summarize it? How do you collect it? Well, can you imagine someone out there collected information about how many children are in your family, right? So you count yourself as one. I shouldn't say children. How many siblings are in your family? So you count yourself as one. And if you have a brother, that's another one. If you have a sister, that's another one, right?